In this lesson, we're going to look at the graph of logarithms. So in the first lesson, or one of the first lessons of this unit, we talked about the graphs of exponential functions. So for example, we looked at graphs like y equals 2 to the power of x. So y equals 2 to the power of x. Remember, it has a point at 0, 1. Actually, I'm going to list these here. It has points, I'm going to start at negative 1, 1/2, 0, 1, and 1, 2. So those are three of the key points. It also has an asymptote at y equals 0. That's the graph of y equals 2 to the power of x. Now, a logarithm is the inverse of an exponential function. So if we look at this logarithm here, if we were to change that into exponential form, it would be 2 to the y equals x. If you notice, that's the same as the exponential function we have here, but the x and y have switched spots. And if you remember from back when we were first learning about transformations, when we switch the x and y values, we call that an inverse. So what that means is that y equals 2 to the x and y equals log base 2 to the x are inverses of one another. So their x and y values are interchanged. So if I wanted to then graph log base 2 of x, all I would have to do is take these values from my exponential function and switch x and y. So here I would have 1/2 negative 1, I would have 1, 0, and I would have 2, 1. So I've just reversed the x and y values. Now I also would switch my horizontal asymptote into x equals 0, meaning I now have a vertical asymptote. Oops. So this was horizontal, but now it's going to be vertical. So if you look at this graph in pink, I've got a vertical asymptote at x equals 0. At 1/2 negative 1, I have a point, 1, 0, and 2, 1. And that right there is the graph of y equals log base 2 of x. I can do the exact same thing for part B. Here, it asks you to sketch y equals 10 to the power of x. So I've done that up here. Remember, your key points here would be, I'm just going to write them on the side here, 10 to the power of x. Your key points would be negative 1, 1/10. This point you actually don't really need. It's an extra for sure. 0, 1, and 1/10. So on my y equals log base 10 of x, that would just be 1/10 negative 1, 1, 0, and 10, 1. So here, you'll see I didn't actually draw this point because it's really, really small. I just drew these two, but we have the point 1, 0, and 10, 1. And again, there should be an asymptote drawn at x equals 0. So my asymptote is at x equals 0. So if we characterize these in general, what you will notice is that now in a log function, so any logarithmic graph, is going to have the point 1, 0 instead of 0, 1 like in an exponential function. The graph will have no y-intercept, and that's because there's an asymptote where x equals 0. The domain will be 0 to infinity, so now our graphs are going to go from 0 to infinity. The range will be unrestricted, so negative infinity to positive infinity, and there will be a vertical asymptote at x equals 0. And that's true for all logarithmic graphs. Now, at the end of the last lesson, we also talked briefly about the idea of e. So here, it's asking you to sketch the graph of 3 to the x, and then sketch the graph of e to the x. Remember, e is an irrational number, sort of like pi, that's equal to approximately 2.718. So if you were graphing e to the x, basically your key points would be 0, 1, and 1, 2.718 approximately. So you'll notice this graph looks very similar to 3 to the power of x. It's just slightly less steep. Now what we know is that when you have e to the x, the inverse of that is y equals log base e to the x, which we learned at the end of the last lesson is ln of x. So if you were going to draw ln of x, or log base e of x, all you would do is you would reverse these points. So you would have the point 1, 0 and 2.7181. And you'll see I've drawn those there. Now what I've missed here, just make sure you also have an asymptote. So that's the graph of natural logarithm ln of x.